Today we will discuss very important topic, that is Nernst equation in electrochemistry. Nernst equation represents the relation between cell potential, temperature and concentration of the solution. It derives the relation between cell potential, standard electrode potential, concentration of ions in the solution and temperature. That is called your Nernst equation. Already you know that cell potential of any cell is equal to, if you tell standard state, is equal to E naught of cathode minus E naught of anode. Cathode means reduction potential of cathode and a reduction potential of anode. Because cathode has a higher reduction potential than anode. This is the representation of standard electrode potential of the particular cell. This is one half cell. That is electrode potential of one half cell and electrode potential of second half cell. That is called your EMF, standard EMF. Generally, Nernst derives the relation E of any cell, at any temperature, not in different temperature, or you can take in standard state also. E of cell is equal to, for example, E cell is equal to E naught cell minus 2.303 RT by NF log Kc. This is the important relation between cell potential and the standard cell potential and temperature, and here Kc is the equilibrium constant. That is called equilibrium constant. This relation is the important relation between cell potential and standard cell potential and equilibrium constant derived by the Nernst. Let a half cell, if take one half cell, let it be like this: M plus N plus Ne changes to M. This is your aqueous medium, ions in aqueous medium, this is the solute. This reaction is a reduction. Because gaining of electron. It is one half cell. M is the metal, here M is the metal, and M plus N is the metal ion of valence N. That indicates N is the valence of the metal, producing M plus N ion. If this is your half cell, so how for this half cell, how you can express the cell potential of this half cell? As per the Nernst equation, that for a half cell is equal to E of cell. Here cell is which cell? Cell is your M plus NM. This is a half cell can be written as like this. So E plus NM, this cell potential of this half cell is equal to E naught value of this cell minus same formula 2.303 RT by NF log Kc we know Kc is the Kc express always concentration of product to the concentration of reactant. This is the expression of Kc. In class 11 we have read in equilibrium chapter. Kc is equal to concentration of product to the concentration of reactant. And each coefficient raised to power. Here there is no coefficient. Here M plus N. That's why Kc is M by N. As M is a solid, solid can be neglected. It is become constant. That is 1. So what is left? M plus N. So here you can write that 1 by M plus N concentration. So this is the expression of this half cell. For all half cell can be written first, it should be written in reduction form. First it should be written in reduction form. Then its E cell will be in this way. E cell is equal to E naught cell of this half cell minus 2.303 RT by NF log 1 by M plus N. Let us take Daniel cell. For Daniel cell, it is the cell of zinc and copper. That zinc Zn2 plus salt bridge copper 2 plus and copper. Already we have read this is the representation of Daniel cell. Let it be concentration of Zn2 plus is M1. Let it be M1 and concentration of copper 2 plus is M2 because it has maybe same or different. Concentration may be same or different. So this is the representation of Daniel. This is your solid and this is your aqueous medium and this is your aqueous medium. This is your solid. This is the fully representation of what? Daniel cell. How the Daniel cell is cell potential will be expressed? Let us discuss. It will be like this. For copper cell, for copper 2 plus and copper, for this, what is the expression of E cell? E cell of this copper is equal to E naught of copper minus 2.303 RT by, what is the N value here for copper? As copper is 2 plus 2E changes to C. For copper can written as reduction form. Already I have told you we should write in reduction form because the data will be always taken in reduction potential. So reduction potential copper, that expression is copper 2 plus 2e plus 2. Here number of electron is 2e. So 2f NF log here which ion? Copper ion. So 1 by Cu 2 plus. Similarly for zinc can be written as E of zinc cell is equal to E naught of zinc cell minus 2.303 RT by here for zinc also same Zn2 plus 2 is equal to Zn. So 2A log 1 by Zn2 plus concentration. Okay, so this is your first equation, this is your second equation. So E of cell, now E of complete cell, this is your half cell, this is your half cell. We know zinc and copper, already you have seen the representation. Zinc is anode, copper is cathode. So E cell is equal to E cell of copper minus E cell of zinc, which is equal to, you put the value of E cell value here. This is the E cell value of copper. E naught cell of copper minus 2.303 RT by 2F log 1 by Cu2 plus. This is the value of E cell of copper minus this value minus E cell of zinc. What is the value of zinc? This value. That is E naught of zinc minus 2.303 RT by 2F NF. N means here 2 log 1 by Zn2 plus. Here, so this is the E cell value of the whole cell, taking anode and cathode. Because already you know E cell always positive. As cathode has higher reduction potential, so E cell will be cathode minus anode. Cathode is copper, copper minus anode is zinc. So E cell, now E cell is equal to, if you arrange this one, the result will be E naught of copper minus E naught of zinc. Then take minus sign. If you take minus sign, then which will come? Which will remain here? E naught will be completed. This minus this. What is left? So when you are multiplying minus sign, already you are taking the minus 2.303 RT by 2F is common. 2.303 RT by 2F is common for both. Then take the bracket. Here bracket is, which will come as your minus sign. So we are taking the minus sign, but as per the data, minus is plus. So which value will come first? If it is minus sign, then it will come first. Which one? This one. Because it is minus multiplied, so already this is minus, so minus is multiplied means this value will come. Log 1 by Cu2 plus concentration. As already it is plus, so minus means it is minus. Minus 1 by Zn2 plus. This expression, we have arranged this one. Now E cell is equal to E naught of copper minus E naught of zinc is called E naught cell. Now this is E cell is equal to E naught cell minus 2.303 RT by 2F. Then log as minus here, so it will be which value? Log A minus, sorry, it is not written here, it will be minus here also, minus log. Log is not, log was not written here, you write log. So what happens? Log, then log A minus log B. Log A minus log B is equal to log A by B. Log A is equal to 1 by copper 2 plus concentration upon 1 by Zn2 plus concentration, which is equal to E naught cell minus 2.303 RT by 2F. Then if you arrange it, it will be log. G will be numerator, Zn2 plus concentration upon copper concentration. So this is the final expression of E cell, that is cell potential of Daniell cell having standard cell potential and temperature and your different concentration of zinc ion and copper ion. So if compare this one, if you compare this value, what you will get? If you compare, the value will be, so this is the E cell, E naught cell minus RT by NF, NF2F log this. This equation says, shows that what? If Zn concentration, zinc ion concentration increases, if you add more zinc ion, you see the equation. If you take more zinc ion is more added, means zinc sulfate solution concentration increases. If zinc ion concentration increases, then minus value will be increased. If minus value increase, then E naught cell is a constant value, so E cell will be decreased. So E cell will be decreased. Very important, will be decreased. What does mean? So Daniell cell, in case of Daniell cell, this is the Daniell cell expression. For Daniell cell, if zinc ion concentration increases, then the cell potential of the Daniell cell decreases. Similarly, if copper ion concentration increases, if copper ion increases, then log value decreases. If log value decreases, then the minus value will be less, so that E cell will be more. E cell will be increased. So how can we increase cell potential? This is very important concept in Nernst equation. How can we increase the cell potential? It will be increased when zinc ion will be decreased. How? Or copper ion will be increased. If copper ion concentration will increase, your cell potential will increase. Copper ion concentration will decrease means If it will decrease, then value will increase, cell potential will be decrease, opposite. So from this equation you can write how you can increase. Another factor T, where if T increases, you see the direct equation, when T will be increased, 30 degree, 40 degree, 50 degree, if you increase the temperature, so this value will be increased. If this value will be increased, then minus value will be increased, so the cell potential will decrease. Very important. E cell will be decreased. So this is a very important relation between temperature, concentration of different ions and cell potential. This is called your Nernst equation, expression of Nernst equation. So what is the standard state? So in standard state, this equation can be written as that what? E cell for this 2 point for any reaction also, if you write in place of 2n, E cell will be E naught cell minus 2.303 RT by NF. Here is n is 2, but for general expression in standard state, general expression that E cell is equal to E naught cell minus 2.33 RT by NF, not 2. Here n may be 2, maybe 6, maybe 4, like this, depends on the equation. 2.33 RT by NF log that one particular ion, suppose metal ion here, M plus N, let it be M plus N1 upon M, suppose it is M1. Here M1 concentration, it is M2 concentration. M1 concentration means concentration of particular ion, here concentration of other ions. But which part will be in numerator? Always which is oxidized. Because in Daniel cell, zinc ion will be above and copper ion will be below. So that will be oxidized, will be written as numerator, and that will be reduced, will be written in the denominator. And here, so this equation in standard state means, what is the meaning of standard state? At 298 K and your mainly 298 K, the value will be E cell will be E naught cell minus 2.303, R value is 8.314 and T value is 298 because 298 is standard state. 298 by N into F. What is the value of F? F is equal to 96,500. F value is 96,500 coulomb. So if this put this value, then log M1 concentration upon M2 concentration. Then if you put the value, so finally E cell is equal to E naught cell minus, if you put the value, this you will get, if you multiply and divide, the result is 0.059 upon N, then log your M1 concentration to M2 concentration. So this is the final expression of cell potential of any cell in case which state? Standard state. This is the expression in standard state. That is standard state. So now we'll discuss some examples. How we'll write different Nernst equation for a particular cell. Let the cell is typed like this: zinc Zn2 plus, suppose concentration is 0.01 m, salt bridge, silver ion and silver concentration is 0.1 m. Let it be concentration like this. For this cell, I can write Nernst equation. So Nernst equation is expression is E cell is equal to E naught cell minus in standard state. Let it be the standard state 0.059 by NF by N. F is already multiplied. 0.059 by N log, which is oxidized? Here zinc is oxidized, so zinc ion will be at the numerator. This is the technique. Then which is reduced? Which ion is reduced? Ag plus ion is reduced. But question is, whether the power will be same or not, we will see here. If you see the reaction, just you see Zn changes to Zn2 plus 2E, then Ag plus E changes to Ag. How can you balance this equation? Here 2 electron, here 1 electron, you multiply 2 here, then electron cancel. You know ionic equation in 11th class. So what is the final equation? G plus 2Ag plus changes to Zn2 plus 2Ag. So this is your what? Cell reaction of this cell. Zinc changes to Zn2 plus, Ag plus changes to Ag. This is the expression of one oxidation, one reduction. Then you combine it to cancel electron. This is your final cell reaction. But here, how many Ag plus is involved? 2. That's why become power. How many Zn2 plus? 1 Zn2 plus. There is no power. This is a very important expression for this. Ag plus 2 to square. Then you put the value. E cell is equal to E naught cell minus 0.059. What is the value of N here? As here 2 electron and 2 also multiply. At in both equation 2 electron involved. In both equation, here right side 2 electron, left side also 2 electron. So generate 2, N value will be 2. So log Zn2 plus concentration how much? So Zn2 plus concentration as per the question is 0.01 upon what the concentration Ag plus as per the question 0.1 square. So you will put the value, you will get the answer. E cell will be calculated. And E naught cell will be given. Either individual half cell will be given or final E naught cell will be given, depending upon the question. So you will solve like this. So very important is the coefficient. Which coefficient you are using? If you forget to write the power, then whole Nernst equation will be wrong. You will get 0 mark. Very important to take care this, to write the exponent, that is power. Whether it has any power will be written or not. So this is expression of Nernst equation in standard state. Now let us discuss some problem. You see, What is the given? Here you see the problem. E naught of Daniel cell is 1.1 volt. E naught is given. Here as the question it is given. Calculate del G value. For this important relation you will note down. For this some derivation, this formula, you remember some formula. Some extra formula that we know del G is called free energy. Free energy is equal to minus NF E naught. And del G is equal to minus NF E naught. This is the expression of free energy change and which one? Cell potential. Very important expression. Directly you have to remember this. Because in class 11 we have read free energy is equal to what? Maximum work done. As del G should be negative. If del G should be negative, then reaction will be spontaneous. That's why minus sign is written. Del G is equal to minus and N is the number of electron loss and gain. F is the Faraday constant. E is the cell potential. E naught cell for all type of reaction is positive. E naught is positive. F is positive. N is positive. Whole del G will be negative. That's why minus NF. And this is equal to also work done. It is equivalent to W, maximum work done. This is equivalent to W because electrical work done is equal to your charge and potential V. Electrical work done is equal to charge into voltage. Here charge is NF, Farad is a charge in coulomb, E naught is the potential. So Q into V is the electrical work done. How much maximum work is done by the cell? That will be calculated from the del G value. Del G is minus NF E naught cell. Another formula that E naught you already have written. E naught cell is equal to your 2.303 RT by NF. Already you have written law of Kc. What is Kc? Equilibrium constant. This expression also another important relation. Okay. Then third formula that del G, if you put this value, this equation here, E naught value, then finally del G is equal to how much? Minus 2.303 RT log Kc. So this equation 1, equation 2 and equation 3, this derived from each other only by taking del G equal minus NF E naught cell. So these are the expression for this. As for the question, what is E naught of Daniel cell is 1.1 volt. Here E naught given. Question number 1. E naught of cell is equal to how much? 1.1 volt. Then what is del G value? So del G, you see the equation. This equation will be used. First equation will be used. Del G is equal to minus NF into E naught cell. Here N, what is the value of N in Daniel cell? N value is 2. So minus 2. F is that is 96,500. 96,500 into how much? E naught cell as per the question is 1.1 volt. If you put, then del G value will be 0.91 volt. Answer will be 0.91 volt in terms of voltage, electron volt or charge. That is the value of del G in the first question. If that will be value will be in terms of here voltage given, here charge given. It will be in terms of coulomb volt. Answer will be that value will be obtained. It will be in the form of coulomb and volt, because Farad is 96,500 coulomb. It is your coulomb and it is your volt. So answer will be CV. Number of coulomb and volt, it will be answer for del G. Then second question. Second question is calculate E cell of the cell. Cell is given. Cell is what type of cell? Nickel 2 Ag plus changes to nickel 2 plus 2 Ag. E naught cell given, and so question is calculate E cell. देखो here cell is nickel 2 Ag plus changes to, because the reaction given is just cell reaction given. Cell reaction, as per the cell reaction, what is the cell expression? E cell, already we have read, E cell is equal to E naught cell minus 2. Suppose in write in standard state, you write in standard state because temperature is not given in standard state. 0.059 by n, then log. Which ion will be written at the numerator? Left. Which ion? Just you see. Nickel changes to nickel 2 plus, it is oxidized, and Ag plus changes to Ag, it is reduced. The oxidized ion will be written at the numerator. Which is oxidized? Which is oxidized? Nickel changes to it will be, because Kc expression is product by reactant. Expression of Kc is product by reactant. So nickel 2 plus will be written at the first. Nickel 2 plus ion upon here how many Ag plus ion? 2 Ag plus. So it will be Ag plus square. Because 2 Ag plus in the equation, you have to write the power 2. And nickel 2 plus only 1. So you can say, and here nickel and Ag are a solid, will not be considered. So this is the value. Then you will put E cell is equal to E naught cell, as per the question is how to find the E naught value 1.05. So you will put 1.05 minus 0.059 by n value. What is the n value? Will be 2, because 2 Ag plus 2 electron and nickel 2 plus also 2 electron. Left side also 2 electron, right side also 2 electron. So by 2. Then log. What is the value of nickel 2 plus concentration as per the question? 0.002. 0.002 concentration upon what is Ag plus concentration? Sorry. Nickel concentration is numerator. Nickel concentration is 0.160. 0.160 upon silver concentration is 0.002. 0.002 square. 0.002 square as per the equation. If you solve as one thing remember, now in the CBC log value generally given. That is one type of hints. As log 4 10 to the 4 given, this is actually log value. So without solving you can write E cell is equal to 1.05 minus 0.059 by 2. This is your what? Log 4. This is your log 4 into 10 to the 4. Don't write this one. Write directly the value is 4.602 into 4.602. So if you solve it, your answer cell potential will be, the cell potential value will be 0.91 volt. It will be 0.91 volt. The value will be 0.91 volt. So in this way you can calculate different problems using Nernst equation. You see the third question. What is the third question? Third question is very easy, but it is the whether it is possible or not, whether reaction is possible or not, it is asked. Whether reaction is possible or not, it is asked. What is that? Question number 3. Just check it. Chromium. Third question, that Fe3 plus ion plus I minus, whether this reaction is possible or not. Fe3 plus can react with I minus or not, we will prove it. Whether the reaction is possible or not, whether feasible or not, we will prove. But we know that for feasibility, E naught cell should be greater than 0. For the feasibility reaction, already we have discussed E naught should be greater than 0. Now we calculate E naught value from the given data. As Fe3 plus I minus. Here Fe3 plus will be reduced to Fe2 plus. You have imagined this thing. That question will not be given, you have imagined. And I minus changes to I2. It will be not given, product will not given. In chemistry sometimes product will not given, you have to imagine the product. Fe3 plus will be reduced to Fe2 plus and I minus changes to I2. Here Fe3 plus is reduced and I minus is oxidized. That substance which is reduced act as a cathode. So which is reduced? Iron is reduced. What is the value of iron here? The reduction potential of iron 0.77. So E naught value will calculate is equal to for E naught value of iron Fe3 plus Fe2 plus minus E naught value of I minus I2 to I minus I2 to I minus because all are reduction potential. So E naught value of iron is after the question is 0.77. 0.77 minus what is the E naught value of iodine? 0.54. 0.54. You see, you may not calculate, but you see the difference is positive. As it is a positive value, so the reaction is feasible. Reaction is feasible. But you see second data, Ag and Fe3 plus. Ag plus Fe3 plus. What is the product? Ag always changes to Ag plus and Fe3 plus changes to Fe2 plus always. So which is oxidized here? Ag is oxidized and Fe3 plus is reduced. That will be reduced, will be taken first. Which is reduced here? Iron. So E of cell will be E naught of iron minus E naught of silver. Ag plus Ag. All are reduction potential. That means reduction potential of iron Fe3 plus and reduction potential of silver ion. You see the value. Your value E naught value of iron already you have taken 0.77. 0.77 minus E naught value of silver is 0.80. 0.80 volt. Result is negative sign. As it is a negative sign, so not feasible. So reaction is not feasible. So second reaction cannot take place between silver and Fe3 plus, but first reaction is possible. You can do like this. You can check whether the reaction is possible or not. How? By knowing the reduction potential and reduction potential of both ion or both species. Which that will be reduced will be taken first. Here Fe3 plus I minus as per the question Fe3 plus will be Fe2 plus and I minus will be I2. So here it is reducing, it is oxidizing. So this value minus this value. In second case Ag and Fe3 plus, Ag will be Ag plus. It is oxidized and it is reduced. So this value minus this value. Not always first value minus second value. It depends upon the which is getting reduced. Here it is reduced means this value minus this value. You have to check whether positive or negative. So fourth question is very important also. What is the fourth question? The fourth question you see that cell is given Cr changes to Cr3 plus, salt breach changes to cadmium 2 plus and cadmium. This is a cell representation given. Write the cell reaction. What is the cell reaction? Very easy to write cell reaction. You see the left side, right side. This is anode, this is cathode. Already we have discussed in galvanic cell. Anode is here, chromium changes to chromium ion. Now you write 3 electron here. Now here cadmium 2 plus 2 is changes to cadmium. That is already written, same thing you repeat. Left side chromium, right side chromium ion. Left side cadmium 2 plus, right side cadmium 2 pi. anode and cathode will be divided in two parts, reactant and product. Then what? R is how much? Here you see the difference. Here right side 3 electron, left side 2 electron. You multiply here 3 and here 2 because to cancel electron. We have read in ion electron method in 11th class. So it will be cancelled. Then what is the result? 2 into 2 is multiplied here. 2Cr plus 3Cd 2 plus changes to 2Cr3 plus 3Cd. This is the cell reaction. But what is the question? Express Nernst equation. Very important this one. Express Nernst equation. How can we express? As per the Nernst equation, we have already written that E of cell is equal to E naught of cell minus how much? In standard state 0.059 by n. What is the value of n here? You see here 3 multiplied 2, that is 6. Here 2 multiplied 3 6. So n value will be 6 here. Overall 6 electron involved, left side and right side. Very important in the expression of Nernst equation n value. n value carefully you have to see. Total value how much? In the right side 2 into 3 6 electron involved, left side also 3 into 2 6 electron involved. Overall 6 electron. So then log which will be written in the first, you see the right side. Once you are writing the cell reaction, always you write the product by reactant. Your product is chromium ion. Your 2 chromium square. Then which ion? Cd. Cd2 plus how many Cd? 3. Q. Then coefficient become power as per the expression of equilibrium constant. All coefficient become power. This is the expression of Nernst equation for this type of cell. You can do like this from using different data. Thank you all.